IQs of 550 applicants to certain college are normally distributed with mean 111 and standard deviation 13. If the college requires an IQ of at least 91, how many of these students will be rejected on basis of this IQ? So the ones who will be rejected equals will have an IQ of less than 91, because you need at least 91 to be accepted. So we need probability X less than 91. Let's say, let's just put it IQ. Probability IQ is less than 91 is what we need. Now, even if we have IQs of, so they're saying that the IQs are being rounded to integers, but normal distribution is a continuous distribution. And anytime you have an IQ of less than 86.5, less than 90.5, so that's going to be effectively less than 91. So is equal to probability X less than or equal to 90.5. So you see, if you are less than or equal to 90.5, if let's say somebody's IQ is 90.5, so that will be rounded to actually 91. So 90.5 will actually be equal to 91 because of this rounding. So we have strictly less here. And anytime you are less than 90.5, let's say 90.4, so that would be rounded to 90, and that would be less than 91. So this is what it would reduce to once we apply continuity correction. So less than 91 will effectively be less than 90.5 in this case. Okay, so this we need to change 90.5 into standard score. So Z is equal to 90.5 minus the mean over standard deviation. So that's 18.5 over, no, that's 20.5 over 13. So that's 20.5 divided by 13. So it's negative 0.04. No, it's negative 1.58. So we want probability Z is less than negative 1.58. Okay. That's the same as probability Z is greater than equal to 1. So Z is greater than positive 1.58. And that's 1 minus probability Z is less than equal to 1.58. So let's look at 1.58. .9429. So we have 1 minus 0.9429. So that's 0.0571. So that will be the proportion, and then number is equal to 0.0571 times the total number. So this is what we got was the proportion who would be rejected, and the number who would be rejected would be 0.0571 times 550. 31.